inspection sheets. These were designed for the different types of motors. We're looking at a standard ball bearing. As we dismantle the motor, we look at all the critical fits, all the things that matter to the motor, like the bearing fits, the journals, the housings, the seal fits, all these different things, the shaft extension size, the keyway, all the details about the motor so that we can identify if it needs repair. Some instruments like a digital caliper for measuring various dimensions. These are really the tools of the trade today. There's some more automated ways of doing it today, but we have a micrometer, OD mic, and an ID mic. Every time we pull out a micrometer in our shop, and this changed about, 5 or 6 years ago, we make the mechanic go to the standard that's in their area that's been calibrated. They go to the standard and they check the mic to make sure the mic is reading properly before we go and measure your motor to tell you there's something wrong. Very important. We found it was the only way to have repeatability and accuracy in the measuring. Measuring sleeve bearings, you're going to get even more measurements in this, but several measurements. This particular one you wouldn't measure because it's wiped. You couldn't measure. That one's bad. This one a little bit better, but measuring in different orientations so you know what the clearance is. OD is measured in the same way, but in multiple places. Outside diameter, then we compare that to the inside diameter of the housing where the bearing fits. And it needs to be a certain tolerance or it could induce vibration or different issues. Sleeve bearings form, the second page of the sleeve bearing form. I'm fast tracking because we're going to run out of time. This is an actual handwritten form of a mechanic that filled out. And we're just going to highlight a couple things. This happens to be the one that we saw the cracked coupling or the teeth were broken. So they're recommending a new coupling. We found that the bearings were wiped. They need to be spun cast. And the seals were wiped or damaged and need to be spun cast. Matter of fact, we couldn't even measure them on incoming because they were so bad. Bad sealed coupling and OD, shaft OD fits. Second page showing the same thing where we documented what we found. Another form is a sleeve bearing visual form that is in the sleeve bearing packet because sleeve bearings are unique and they have little things like oil ring keepers that kind of keep the oil rings in the right position, or they have oil rings themselves that we need to identify and look at and inspect. Sleeve bearings, obviously, but we're looking here now, not just dimensionally, we're looking at is the material bonded to the shell? Is the insulation in good shape if it's an insulated bearing? Are the temp probe holes clear? Is the anti-rotation slot or the pin on the top of the bearing in good shape? Just all these other details. Measuring again, measuring, like a housing, using a dial bore gauge. Typically we'll use a dial bore gauge on a bearing that's been spun cast and finished because it's a great way of getting inside and getting a measurement. Obviously on a bearing that size, you can't even get your hand in there, so you have to use a device like this. You wouldn't be able to use an inside mic. Runouts, standard AC runouts, armature runouts, and then just quickly run out in the lathe. We're zeroing the journals, and then we're taking that indicator, we're moving it along the lathe, and we're indicating, finding out the runout at different points on the rotor. And then we're referencing that back to the journals that are zero, because that's how the motor operates, right? It operates in the bearings. That's the centering point of the rotation for the motor. Everything else is in reference to that.